Okay, just thumbs up to everyone on Zoom if you can hear me well. Thank you, Johan. Yes, why is this not switching? Okay, we can go ahead and begin. Happy Monday, everyone, and let's just speak a little bit, of course, logistics, and then we will dive into our modules. So, just a quick announcement that I have made today is regarding the internship that is happening in October 1st. So I know most of you are planning to graduate soon or you're about the finishing mark. So this is really good if you would like to check it out. And I've been to one before. It's interesting. There's a lot of companies that do come. So it's a great way for you to connect and put your resume and get your name out there. So this is optional for you, but highly recommended if you are planning on going. Make sure that you go early because the line tends to be longer. So either you go near the end, which most companies start leaving towards the end, but if you go early, it's better such that you will secure your way in the line. Has anyone went to these before? No? You went? How was your experience?
It was chill. There were like so many people, on computer science, of course.
Okay.
So a lot of the booths that I needed to go to, there were like 50 plus students there at all times. A lot of the business focused booths and I'm one like technical engineering booths were a lot more empty.
Yes.
I know Lockheed Martin had a whole queue.
Yeah, they did. Even Harris, right?
Yeah.
Yeah. Yeah.
But other than that, it's good to get a feel for what companies are out there.
Exactly. Yeah, I think on their website they do announce which companies are planning on coming. So maybe you can adjust your resume based on the company. Uh, is there a fast pass when it comes to these?
Yeah, it's like a
Is it you have to purchase it?
it's not something you have to purchase. It's
Okay.
more like you have to first come first serve.
Okay,
Yeah,
I see.
it's like QR codes and
Okay,
just get in early.
sure.
That's a lot of it.
Yeah, I think it was good. It's just that I think what I can give you as an advice to you guys is that when you do talk to specific recruiters from certain companies, make sure you check up with them. They tend to get a lot of resumes that get handed to them. So your name, or I mean, they mean a lot of students, so you will not be remembered in the essence. Not that they will not remember you, but there's a lot of students, so it's good to reach out. Also connect with them on LinkedIn, maybe at the same time or after the program finishes, and just remind them as a message. And then usually if they work for a specific company, it's best to follow the company as well, because if there's any postings that get opened, you will be announced. How was your experience? Same? Yeah. Okay. Yeah. What do you think could be enhanced to make it more efficient or better? And then, or is it?
I'd say a lot more organization.
Okay.
Because last time I went, it was just like always filled with booths.
Yeah.
It was just.
Then
People get shoulder bumping.
yeah.
Just trying to shove your way in.
Yeah, I think the engineering last time I went, it was they isolated to the back. So then you would have like the general positions like educational, like the police officers and stuff. These are like very empty in the front, and then engineering is more, yeah. So I think having that switch would be a good idea. But yeah, it's good for you to check out. There's the direct link if you want to know more about it and all that details. Okay. So let's dive into our modules and where we are currently in the class. So currently we're in week 6, and today is kind of this week specifically is going to be partial of the application layer, where we're going to wrap up the application layer, and we will also speak about the transport layer. So the transport layer will start on Wednesday. Today will be dedicated for the application layer in terms of the socket programming assignment, which will be released sometime this week, either tomorrow or Wednesday. And I'll send an announcement about it. It might seem that like you have a lot of assignments that are due now, but this class is considered, the way I view it is we don't have a lot of assignments, but the assignments could be a little bit heavy. So after this specific assignment, we won't have anything, and then we'll have our midterm, then assignments will resume after the midterm. So you currently have lab 1, the Wireshark, and homework 1, which is related to the application layer, and the socket programming is going to be related to the application layer as well. And it's going to be quite simple after we talk about it today, and then we will have our midterm, which is going to be roughly in October. It's probably the second week or third week of October. I'll announce more when it comes to it. Obviously, as I said before, it's going to be online take home, as we have 2 sections, and the higher section is the online students. Yeah, that is it. So let's go ahead and start. You can download these Python files for the socket programming and follow along, because we'll do a little bit of hands-on. And yeah, so diving into our lecture. Just an acknowledgement, this session is being recorded, and as some of the slides are borrowed from the book, and the direct link is found to them there. So here's where we are in the application layer. We covered most of the application layer and all of it. This is the last section of it. We will talk about the socket programming with UDP and TCP. But we covered the application layer from several views or phases. We talked about the network applications, the applications themselves. We talked about the web and HTTP, and we did a little bit of hands-on with that, with Wireshark and mobile Xterm using the Eustace server. We also spoke about emailing and how emailing works with the SMTP protocol and the IMAP. And we sent an email in one of the labs, one of the lectures as a demo. Also, the DNS domain name system and the various records that it provides us that are useful. We also did a little bit of practical on that to see how we can trace or attain these specific records. We talked about video streaming and content distribution networks, how companies and real world enterprises, when it comes to content, how they would distribute their content such that it reaches all users, and the bandwidth is good and open such that there will be no jitter or delays. So this is the last part, socket programming. So, and we said that an idea of sockets, they're the API between the application layer and the transport layer, and they provide a programming interface to the internet architecture, and we'll cover the socket abstraction and how applications would use it. And then we're going to do it for our 2 transport layer protocols, the UDP, user data protocol, and the TCP, the transmission control protocol. So, and we will have an example of a client server application implemented in Python, and then we'll see how the application quite works. So when it comes to socket programming, or the essence of socket in the OSI model, our goal is to learn how to build a client server application that communicates over the internet. And the way that application would tend to communicate, they would communicate through sockets. We said that with applications, they can have various processes. So these processes would be specific tasks that are related to the applications, and the socket is the interference that would deliver them from the client to the server. So if an application needs direct use to the internet, then it has to use the transport services, then it must go through sockets. So this applies to all operating systems. Applications that are user space run outside the operating system, and then transport layer and the layers below are inside the operating system. So the socket, you can think of it as kind of like the door between the application code and the transport protocol stack. As we said, there's the internet socket APIs, They support two transport services. TCP is more reliable, sends it's more reliable, controlled, helps us with congestion control, sends packets and frames in order. UDP is more unreliable, datagram-oriented services. It just pushes out the data, and we will work with both of these today and practice with them. So this slide, or I mean, in the assignment, you can use any programming language that you want, but to demonstrate the idea here, and in this slide, we will use Python. So here's a simple application example that we'll implement very soon, but first we just want to talk about the idea. So the idea is that a client reads a line of character from the keyboard and it sends it to the server. The server would receive the data that is being sent from the client and then converts it to characters that are uppercase. And then the server would modify the data to the client, sends it back, and then the client would receive the data. So while like this is simple, the example shows like the essence of of socket programming. And we want to understand how the application layer interacts with the transport layer and how client-server communication is being done in practice. So once you understand the model, you can design more maybe complex applications using sockets. So as we said, with UDP, there is no connection between the client and the server. There is no acknowledgement when the data is getting sent. So no handshaking is needed when it comes to UDP. Each packet is being sent independently. When sending, the client must include the server IP address and the port number in every packet, and this is related to the networking layer, such that when we send packets, we need to use the source, the host IP address. So we use the IP address of the host, and we also use the port number that gives us that gets assigned to the specific task that we are doing. So once receiving, the server extracts the client IP address and port number from the incoming packets. So some of the characteristics of the UDP data transfer is that packets or datagrams can be lost during transmission. There is no guarantee of reliability or integrity of the data. And then we said that the packets can arrive out of order as well. So from an application viewpoint, and usually UDP is used more for streaming or broadcasting, is that it provides unreliable, unordered transfer of datagrams between the clients and server. But the important of it, or I would say the pros of it, it is very lightweight, but the application must handle the errors or order if reliability is needed. So that is the essence of UDP with sockets. So here we have an example of UDP, then we will move on to TCP. So we have a server and we have a client. So generally we want to show the step-by-step interaction that is being happening between the client and the server with UDP packets. So UDP is a little bit simpler compared to TCP because it does not require connection. There is no handshaking that is required. And the first thing that would happen is that because sockets are getting used in both sides, the server and the client. So the first thing is that the server and the client would create sockets. And this would be, if we look at the server socket equals socket AFNet, INET, and then socket datagram. And then the client would do the same thing. So that is the first idea. The parameters that we have, AF/underscore INET, and then socket datagram. The AF_INET would specify the IP version 4 address. And then the socket datagram is the specific UDP datagram sockets that is going to be attached with the packets. So the client doesn't specify a port number. The operating system usually assigns one, but today we will assign one manually ourselves as well. And then on the server side, the socket will be bound to a specific port number because the server has to have a static port number such that the clients know how to ping it. Usually that is static for the port number and the IP address, such that we can ping it over and over. Okay. So what would happen after that is that we have the client. It will send a datagram, and basically this is maybe called as a process. So the client prepares an application layer message, and this could be a line of text. The example that we have is going to be a line of text. This is what we're going to work with today. We're going to, as a client, we're going to input a lowercase sentence or a word, and then we will hope that the server acknowledges it and then sends it back in uppercase. So the client, once he sends the first request or the first message, he must include the server IP address or host name resolved via DNS, and also the port number. So these are the two characteristics that must be included. So example of the IP address, it could be any IP address that we have, and the port number is going to be the one that is static. Something to note as well is that the internet has no central directory that maps the service to the servers. So the client must already know the IP address and the port through configuration, documentation, or DNS with the various types. So then after the client makes the initial request, the server would receive the datagram and would not send an acknowledgement back, obviously, because we are using UDP. So the datagram would travel across the network and it reaches the server host machine. The server socket would pick up this specific socket that is getting sent, and then this is going to include the payload that is being sent, which is basically going to be our sentence, and includes the IP address and port number from the client as well. So the idea is that UDP sockets allows the server and the client both to receive messages and automatically learn the return address. So we don't need to specify those details over and over. It just for the initial reach out, we need to know it. So once the datagram gets sent to the server would prepare the request, and it would reply or would write the server socket specifying the details. So the message that it prepares is going to be related to the task that we have. So it's going to be converting text to uppercase. And then it sends the message back into a server socket attaching the client IP imports. After it gets sent back, the client would read the datagram from the client socket, and then it would close the connection. So that is ideally the communication that would happen with the client and server within UDP. It's a connectionless, so there's no setup or tear down messages that are in exchange, and there's no reliability that guarantees the packets the packets that are getting sent. So it could be lost, it could be sent in order, and or arrive out of order. So for us to use TCP, and the use of TCP is for reliability, and that it helps us with various things, such that it is used for error detection, retransmission as well, and that's why we use TCP. So common uses for UDP is going to be ideally like bless you. It's going to be ideally like voice over the internet, streaming video games, where speed is more crucial than the guarantee that we need. So, and we spoke about that more when we spoke about the protocols itself. Ideally, the application needs to understand and know what is the use of the application and the motive and the goal for it. So now looking at the exact Python example for the same slide that we discussed in the previous, the idea is that the program will take a lowercase sentence from the user, send it back to the server over UDP, and then the receiver would receive the message from the server in uppercase and then prints the results. So this is the client side of the model that we've been discussing. So talking about it step by step, the first thing that we need to do, and is crucial, is obviously to import the libraries. This is the first thing that we have to do. So we import the Python socket library, and this is the first line that we do. This gives us all the functions and constants that are needed for networking. After that, we create a UDP socket for the client, and we're using the different parameters that we discussed. That gives us a datagram. So the IP address and the socket datagram, that's going to be assigned to a specific packet. After that, the message, which is going to be usually the input. We're going to do, we're going to make the user input something as a sentence, and that will be sent over to the server for processing. Here in step 4, we will attach the server name, port to message, and send into a packet. And the message is converted into bytes using .encode. And then here we have the read reply characteristic from the socket into string. So the client would obviously have to wait for the server response. And then the reply is received along with the server IPs and the port info. So the server response should be uppercase of the version of the original message that we have. And then finally, printing the results and closing the socket is the last step. So the client decodes the bytes back into a string, and then it prints it into uppercase message on the screen, and then it would close the socket. And usually with TCP, the connection can remain open for other requests or other objects that are getting requested or other processes. Now looking at the server side of the application, of the UDP applications, and the server job is to wait for a message from a client, see what the sentence or the word is, and turn it into uppercase, and then send the modified version back to the client. So unlike the client here, the server will keep running, and it's ready to handle multiple requests. So that's why when we run the program, we have to run the server first, such that it is ready to take requests. So then we will run the client after. But to break it down into 5 steps is that we also have to create a UDP socket for the server, and this is going to take the same parameters as the client. We have to have a local host, a local port number, such that every client or every request is pingable to the server. And here, the empty strings that you will see, let me show you. Here, the empty string that we have is an indication such that we can accept a message from any IP address that we have. So this ensures that like any IP address can reach out to the server and send a message. Obviously, we said the server will stay on, so we have to have a loop. So while true, there's going to be a loop forever. This will keep the server running continuously, waiting for the client request. And then, unlike the client, the server does not exit after one interaction. It will remain open unless we actually close it ourselves. And then finally, the main important thing is that the request is getting sent back to the client. So we are sending the message in uppercase back to the client. So the server sends the modified version to the same client that it contacted. So and then the loop continues such that we wait for the next client message. So that is UDP and how it works with, and we've seen an example and how it would work with sockets. So far we looked at UDP, and now we want to look into TCP and see what is the difference. So UDP that we said it's connectionless, and there is no connection that is being done. Now we are shifting to TCP, which is more connection oriented and more common used in practice. And a use of TCP, emails use TCP such that when we send the data, we don't really care about how fast it gets to the client. We know it will get sent, but the integrity of the data is very important, such that it should not be sniffed or interpreted. So the same idea with UDP, the client first must contact the server, and the server must also be running, just like the UDP. The server would create a welcoming socket, same thing essentially, that is a door that waits for incoming connections from the request from the client, such as request. And the client itself would contact the server. It would also create a TCP packet. It's the same as UDP. We're going to create a TCP packet that includes the IP address and the port number that we have. And when the client socket is going to be created and used to connect, TCP automatically establishes a connection, and that is the server welcoming the socket. So this is a three-way handshake, which we will explore more in detail. And then what happens on the server side of TCP, when contacted by a client, the server would create a new socket as well that is dedicated to this specific client. And that is important because it allows the server communication with multiple clients repeatedly, or in the essence of in a loop. So each new connection has a unique combination of IP address and a port number. So if we have two different clients that are pinging the server, obviously each one would have its unique IP address and unique port number. And then how to distinguish between the source port numbers is going to be something that we will dive into in chapter 3 when we talk about the transport layer itself. So from an application viewpoint, the perspective of application using TCP is for reliable ordered byte stream. And there's a pipe between the client and the server. Bytes go in one side in the correct order, and then they come out of the other side in the exact same order without loss or duplication. And that is very different from UDP, that we said that packets can be lost. So here we're going to look at the same idea that we had with UDP, but this time it's going to be TCP. We have a server and a client, and we want to look at the interaction that would happen between them. As we said, TCP is not unlike UDP, it's connection oriented. So before the client and server can send applications to each other, they first must create a handshake to establish a connection, then the request can be made. So okay, let's begin with the server side this time, because the server needs to be up and ready, waiting for the client's connection request. So the first thing that it does, the server would create a socket, which will wait for incoming connection requests from the client. And this is called the welcoming socket, or maybe the listening socket. This is the socket that waits for the initial contact, but it's not the socket that goes through which application level messages will flow between the client and server. So this is essentially just used for the handshake. So after creating the socket, the server invokes the accept method. This on this welcoming socket, this is a blocking call. It causes the server to wait until a client reaches out. Now, when we head to the client side as well, the first thing that it does, it will also create a TCP socket that specifies the server name and port number to which this socket will connect. And then after creating the socket, this is essentially the handshake. The connection is set up. The socket on the client side will create a TCP connection request message to be sent from the client to the server. And then the connection request message is sent with the transport layer when the client invokes the socket method, not by the application itself. So the connection request comes from the client, which is what the server has been waiting for. When it's received at the server, there's two important things that will happen. And the first one is that a new socket is going to be created for the server and returned to the server side application. This is because we said that we create a socket first for the handshake, and then we need one to accept the calls. This one is gonna be the one that's gonna be related to UDP, which serves the application, serves the client when a request comes in. And then we also have a TCP level message that is being sent within the server operating system, not the server itself. And this will tell the client that the connection has been established. And these specific handshakes also we will look in chapter 3, because our next chapter is going to be about the transport layer, which is something important, is going to be related to this handshake as well. And then what would happen is that the client and server would exchange messages. It's going to be similar to UDP, but there's acknowledgement. The server now, the server-side application would use the newly created connection socket to communicate with the client. The welcoming socket is only for listening and remain open and separate. So the client communicates using the client socket that is created earlier, and this is the only socket that it has. So when it comes to the server, we create two different sockets. We create one for the welcoming message, or essentially for waiting to hear a request from the client, and then another socket that is being exchanged with the client for requests. Here we will look at the Python version of the TCP client. It's the same idea is that it's going to take a user input, send it to the server, and print a reply. Because there is a TCP connection oriented with TCP, there is going to be a little bit of differences when we compare it to UDP. So we said that the first thing is that we create a TCP socket for the server, and we can assign one that is not already determined, or already that is out there. Maybe that is specified by the IEEE, or there are specific sockets for specific tasks, or there are specific port numbers that we have for specific tasks that we have. So we cannot use them essentially, but we can create a unique one for our task. So it creates the socket first, and it attaches the client, attaches the IP address, and also the port number to that. And the second thing is that there's no need to attach the server name again and again. The port number is needed for every message. So unlike UDP, the client does not need to attach the server address and port number each time it sends the data. Once the connection is established, we can send multiple requests, and we know it based on the socket that is being created. So the client can get user input, which is the sentence. It sends the message with the client socket.send. Then it receives a reply with the client .receive. So finally, the result is printed. So in TCP, the connection setup replaces the repeated, or the essence of needing to attach the address info, unlike UDP, because it doesn't have a handshake connection that gets established in the beginning. And this is important, such that if we are sending maybe a mail to a specific house, and when we get to the carrier, they already have the specific house, so we don't need to specify the address over and over. It's kind of kept in there. So that's just to give you an idea of the difference of TCP and UDP. So once a connection gets established, the client and the server can exchange data seamlessly until the connection is being closed. The server is going to do the same thing as UDP. It's going to wait and process the request and send it back. So first thing that we do is we create a welcoming socket, and this is just to hit here or wait until it gets pinged by the client. Bind and listen. The socket is bounded to the specific port number that we have, and it listens for incoming requests. We also have a while loop, or a while true here, is that the server runs inside while true, so it can receive multiple requests. Also here, this is for accepting incoming requests, such that it would wait for a connection or a request that would happen from the client. And then when a client arrives, a new socket will be created. This is the socket that is going to be used to talk to the clients. So the welcoming socket stays open for future clients. And obviously here we will read the data that is being sent from the client. And then we will convert the request to uppercase. This is our example. And send the modified string or send the modified sentence back to the client. And then here, this specific socket will get closed. That is, this is the specific socket that is related to that request, but the welcoming socket will remain open and ready for the next client. So we will do a little bit of hands-on to show you the UDP, how it works, and TCP, how it works in just a minute. But we completed our study of the network application layer. So I just want to do a recap while then we will do a little bit of hands-on. So the main ideas that we discussed when it comes to the architecture, we have P2P, and you should be aware of that, where the two nodes can act as a server and a client, depending on which one is sending and receiving. We have the client. This is a centralized server that has a static port number and IP address that is getting pinged by multiple clients. For the application service requirements, they often require different levels of service. And we said, is it reliability? Is it bandwidth? Is delay tenable or acceptable within the app? TCP we spoke about more here, and UDP as well. We know that TCP is more connection oriented, reliable, ordered byte stream, and then UDP is connectionless, unreliable datagram, but it's faster, but it does not give any guarantees. We talked about HTTP as well, and we talked about how HTTP uses the vanilla TCP, and it would use TLS for the encryption and the integrity of for several causes of the security and privacy point of view. And then we spoke about the different HTTP versions. We also spoke about persistent and non-persistent HTTP, such that persistent will remain open, the connection will remain open for multiple objects to be sent and requested, but the non-persistent will be closed per object. The email transfer and retrieval, we talked about using the SMTP. The SMTP is the initial protocol that we use when sending emails. And we gave an example of Alice and Bob. Both have their own individual mail servers, such that we first write the message that we want and we send it to our local server that will store the message. Then that message will get sent to Bob's mail server, and then it will get pushed using the IMP AP protocol. DNS we talked about is just a way of translation, translating host names to IP addresses, or vice versa. We can have the host name and we want to know the IP address, or we have the IP address and we want to know the host names. We talked about other applications that we have, video streaming and content distribution networks. How do we deliver multimedia content at scale and to various users in a higher or far geographical location. And then this is the socket programming that we will do in a little bit. Most importantly of chapter 2 is like the network application layer is the protocols that we needed, and this is the essential thing. And I think the top to bottom down approach is a really good approach that gives us first the application side of things, then it goes to the networking. So everything we study will resolve around the protocols. Even in the transport layer, we will also refer back to the application layer. So a typical client request would look something like this, where the client sends a request info to a server or for a specific service, and then the server would respond back with the data and the status codes. That's when it's related to HTTP. We talked about the message format. These are the headers that will contain crucial information about the data. and the payload is the data that is being sent itself. Important themes that we discussed about centralized and decentralized, stateless and stateful, scalability, reliable and unreliable, message transfer, and the idea that when we hear complexity and network edge is how intelligent complexity often lives in the application layer, so close to the users. Such that the infrastructure of the network is already made and for us and is available. The complexity is going to be mostly related to the application in terms of making the application and knowing what exactly we want to get from the application. So that is it for chapter 2. This is the application layer. We will do a little bit of demonstration to see how the TCP and UDP work exactly. I'll share my screen. So these are the files that I will be using for today, and you can download them as well. These are the demo files. The assignment will be something very related to what we demonstrate, and this is oftenly what we see in class, even with the assignments, with the Wireshark or the DNS. That is something that we implement very close, and the idea is that you implement something that is related to it just to understand the idea. To begin running the files, you can use any IDE that you want. Could be Visual Studio, Jupyter. It doesn't really matter. But here, because we are working with a server and a client, we will use the Eustace server. So I'm gonna refer back to MobaXterm. And if you're using Mac, you don't need MobaXterm, or I mean, it's not even available to you. But let's go ahead and launch MobaXterm. And we're gonna start local terminal. We're gonna SSH to the server. Does anyone know what Eustace, what is the name of Eustace coming from? Like, or what does it mean? No?
It's city and last.
Oh, okay, it's big.
A lot of easy, that makes sense.
Yeah, when it comes to,
Right?
yeah, no,
It's like northwest.
oh, really?
Yeah, it's
Okay.
only like 30.
I see. Eustace, okay, I forgot Eustace, there we go. Okay, so that is important. And you can use the Eustace 3 server or the Eustace, the regular Eustace. And it's really up to you. It's not gonna be, you're not gonna be held to use a specific server. Sometimes it takes a while for it to accept. Yeah, there we go. So once we have that, we will need to open another terminal that we need to open. We can put it here. So for the program, we don't need to have two different servers for it to work. Like for in the essence, we don't need to connect to Eustace 3 and then regular Eustace for the program to work. We can do the program and run it successfully from the same server. So I have tried both. You don't need to use two different ones. You can use the same main Eustace server. Okay, so since we are logged in, this is the first step that you need to do. I think for Mac users, don't you need to use a specific command to upload your files? I think it's okay. Yeah, exactly, and then change for. Yeah, if you're a window user and using Mobile Xterm, you can just click the upload file. You need to get your Python files on the server. So we will first do the UDP. So and if you are using Python, does Python come installed on the server itself?
Well,
Because
I'm not sure. I use Visual Studios, but I know like I think it's already in there.
yeah, I think it's already on there.
When I ran Python programs, I didn't have any, so I think it's already pre-installed.
Yeah, I think so as well, because I uploaded the files and I started running it without needing to install Python. And you can verify by the version that you have. You're gonna need Python 3 for it to run, and we have 3.12, so that is good. So let's just get a clear or a better screen on both ends. First thing that we're gonna do is we're gonna run the UDP server, and this is the initial thing that we need to do. Usually we run the server before the client. So we're gonna run server UDP. And then now the server is ready to receive a connection. It's waiting for a ping from the client. And a cool thing here is about, I think also if you're using Mac, there's a specific command that you can edit the file on the terminal itself. With the Mobile Xterm, you can just double click it and then edit directly on there. So you don't need to but once you save it, only saves to the server side. It does not save it locally where you have it stored. And this is the same thing that we discussed in the slides. I made it very documented such that you can refer back to it and understand what's going on. So here we are running the server side. We need to run the client side. And then obviously the client side is going to ask us to input a lowercase word, and we can just do hello, and we send it. We send it to the server. Obviously, with the UDP, it's not going to acknowledge that a message is being sent. It just delivers the data so that we are getting the request back that we have. And then the client side, the request, it gets closed. But for the server, we have to close it manually. So maybe another client can ping the server again, and that the UDP has remained open. We can do another, and you can type in anything here, and then it would exchange it to uppercase. Okay, so we are gonna end it here. Sometimes what might happen is that once you end the server for the UDP and then you run it again, sometimes it tells you you have to choose a different port number, and that usually happens because there is a specific time constraint for the port number that gets assigned to the server itself. So then you would have to, if that usually happens, you have two things you can do. You can either change the port number, just assign something else. If we look at the server UDP. So here we have the port number we said because it needs to be pingable by the clients. We can either wait for that time constraint or we can just change the port number. So the same thing would happen here. We would run the client and then we try again. And then it would apply. So that is the UDP. It's non-connectionless. It is faster, more lightweight, but it does not guarantee us the integrity or reliability of the data or the order of the byte stream. So let us run the client next. And when running the client, we obviously do the same thing. We run the server for the TCP. And now here the server is ready to receive. When we run the client here, client TCP, it would ideally it would request the same thing from us to input a sentence. And then here we are getting a reply from the server. The connection would remain open on the TCP itself for other connections that should be sent. and that is usually for TCP. This one here specifically, the code for the TCP of the client, it usually closes out the connection. But we know that with TCP, the connection needs to remain open, such that we end it ourselves. So we need to specifically as a client say, hey, we are done with this. And this is why I have created the loop version of the TCP. And this is to keep the loop. And I just wanted to demonstrate this for you. The TCP and UDP kind of works the same, but the TCP now we will see the difference of it. So we will run the Python server TCP loop. And now it's going to say the same thing. The server, first it creates the initial port, the one that waits for a ping or request from the client. And then here we run the Python client TCP loop. Okay, so it's saying, hey, this is where the handshake gets established, as we showed in the slides. It is saying that this specific IP address of which is basically this side of the portal has requested with this specific port number. And as we said, each process would have its own port number but for each connection, the port number would remain the same. But every established or every connection that gets established will have a port number. And usually that is dynamically assigned by the OS. So now it's saying it's connected. We can here do the input, and the server would say, hey, I received the message in lowercase. I will reply in uppercase as instructed, and then it sends it back. But you notice here that the connection remains open on both sides. For us to end the TCP the connection, we have to type in quit. But if we want another request from the server, we would do another thing. So then the idea gets repeated over and over until we are done, and we would type in quit to exit. So the server is saying, sending you a message saying, hey, goodbye, but the closing connection on the client request, but the server remains open still. So as we said, the server gets closed and remains open for the idea that other clients can ping it. So if we run the program again, we will receive the same IP address because our IP address most likely is going to be the same, but the port number is dynamically changed. So the idea gets repeated again. We would type in quit. The server still will remain open. And the connection here for the client will end. So that is the idea. I hope that the demonstration with the slides made the idea of TCP and UDP clear to you. In terms of the programming, it is very basic, and it's not really that much in detail when it comes to the assignment. And you can use any programming language that you want. Something that is very cool that we can that you can do as well. Here I tried doing, but it did not work. We can capture the Wireshark traffic, but here, since we are running the code on the server, it would only show SSH traffic. It would not show the traffic that is being done. But once you are working, you run the code on your IDE. If you are running your code on IDE, you can start the tracing, and then you can see for UDP, you can interpret the data. It is not secured, so you can see what is being done in hex and hex view, and you can convert it back to maybe ASCII. So that is something cool, but this is a little bit over the scope of the assignment or the program. The assignment will not require you to do that. It will just require you to do something similar to this. Okay, so that is it. Lastly, what I wanted to do we have any questions related to the assignment to the socket itself? Because lastly, I wanted to talk about homework 1 very quickly because I know it got released, and I like to just to briefly go over it such that to give you an idea of what's going on. So the homework is not due is due September the 28th, so I think that is this coming Sunday, right? Yeah. And then our lab 1 is due this Wednesday. So I'm hoping that the deadlines is enough for you to get your assignments in. So for homework assignment 1, here the first, we will have 2 questions related to HTTP, 2 questions related to DNS, where we have a scenario-based questions, and then we have the SMTP protocol. So the first ones are very easy. You just need to explain if it's true or false, given a statement, and then explain why. For the HTTP, we did something similar to this in class already with the MOBA term and the git command using telnet. So, this should not be an issue for you. So yeah, the idea is the same here. You will log into your Eustace, either on mobile extern or on your command line, and then you will get these specific thing. So for this specific website, the second one primarily, once you connect to it as a host and your telnet into it, once you request the GET request from the main path or the main homepage, it will tell you that has been moved. So just knowing that the request that you do get back saying that has been moved, request it based on the new path that it specifies for you. Once you get that request, is that understandable? Yeah. So first, when you do request, you're gonna get it has been moved. So then just go back and request whatever the new file. Okay. And just with every question, attach your screenshots and just simple steps on how you got the answers. DNS for the various records we focused on the UCF website here. It's talking about the cs.ucf.edu. Here, just a scenario based. Supposing that you up on a nonprofit, what would you need? And the SMTP, I hope, is also going to be very smooth, such that you use teleport port 25, and then you send an email, just show a screenshot, and just follow the details. So I think this is where we at so far. We wrapped up application layer, chapter 2. We will start on the transport layer next. Our midterm is going to be around October, I think the second week to be exact. That same week you will not have a lecture. You just have a whole week to get prepped for your midterm, and then the midterm will get released. You probably have about 24 hours for it to turn it in. It will be take home. And don't expect something to be very difficult. It's going to be just related to something to the homeworks, okay? That is it. So if you don't have any questions, you are free to go. And I will see you on Wednesday.
I mean, you also on this first couple months of class. I heard you mentioning the career fair.
Yes.
What was that also?
So the career fair is something that UCF host. Yeah, have a good one. Something that UCF would host on every semester, fall and spring. They usually don't host it in summer, but you would find a lot of companies that would come to these interventions or to this career fair. And then you can go as a student to try to connect, get your name out there, to maybe find an internship or a job. It's very recommended for students that are just starting to get an internship, or for students that are about to graduate and they want to land a job. So just a way to get your name out there and connect with different companies and recruiters.
What would you say for the dress code, like suit and tie?
Yeah, business casual. So suit and tie. You probably don't have to wear a jacket. You can just wear your common suit shirt, and not even a tie is necessary. But the shoes have to be obviously shoes like suit related, and then slacks is also fine. But they do have on their website, I think they have a video of what to wear, and they give you like an X or a check mark on what you should wear. But one tip to give you is arrive early. So if the event starts at 12, I think arriving 2 hours before is best. I'm not sure. Is it 2 hours good?
Claris is great, but
Dennis, I have received your comment and usually just give me one moment. I have received your comment and I will just reply to you via email. I keep a copy of the transcript, so I will reach out to you regarding your question 4. Is that fine?